on network engineers. And my name is Abhijit. You can call me AB for the ease. And I am going to be the instructor for this entire training. And before we dive into the course outline, the introductions, and all that stuff, I would introduce about myself so that all of you get to know about me, my experience, uh, and it will also help you identify how much benefit that you can take or that you can get out of this training when you actively participate, given that the type of experience that I bring on the table, being an instructor for this training, can help you in a very positive and in a very productive way to build your skills around DevOps and how DevOps tools can be utilized for doing network automation. So, speaking about myself, I started my journey back in 20, uh, I would say 2012 or 2013, where I started delivering workshops and faculty development programs and all that in many engineering as well as engineering colleges as well as universities. And at that time, I used to teach about networking, about CCNA, right, about network fundamentals and all that. And then I did it for a couple of years, and I have, I would say, delivered sessions and workshops and seminars and all that in around more than 200, I would say, colleges or universities in India. And after that, I upskilled my knowledge to a professional level curriculum where I did my CCNP certifications and I started teaching about CCNP routing and switching to corporates. So that's when I stopped visiting colleges and universities and started delivering professional level trainings uh, to various corporate organizations all around the globe. And when I was actively doing that, I got introduced with few of the solutions which were getting very popular at that time. I'm talking about a timeline around 2014 or so, where Cisco, which is kind of a renowned organization in our domain, they came up with few solutions which were termed as Epic EM, Epic DC, right? And there was also something IWAN, and there were others also, Prime Infrastructure, right, and others. But these few solutions which I got to know about, these solutions were about changing the way how network is or was being managed. Because earlier, irrespective of the type of the infrastructure which you have, you would always go and manage the infrastructure directly by taking access of it, either by local means or by remote means. So these solutions, we're talking about changing the way how network management is done, right? And that is where these solutions were introducing various controllers. And nowadays these solutions are known. They have rebranded the solution. So Epic EM nowadays is identified as SD Access. I'm sure all of you have heard about this. Epic DC nowadays is known as ACI. IWAN have cultivated to become SD-WAN after their acquisition of Viptela and all that, right? And each of these solutions manages a certain type of infrastructure. Like the SD Access manages kind of the campus infrastructure. The ACI manages the data center Nexus 9K switches. The SD-WAN manages all the branches or branch fabric that many enterprises do have. And all of these solutions, they do follow something called SDN, or on architecture of SDN, which is software defined networking. So while I was delivering those trainings back in about 2014 or so, I got introduced to this terminology, and I was blown away by the fact that it changes the entire way how you communicate with your network infrastructure in terms of management. It doesn't change the way how the data plane forwards the traffic. It doesn't change the way how protocols work. Your OSPF still gonna behave as it does. Your BGP is still gonna behave as it does. But it was changing how you would be configuring OSPF, BGP, and other things on the network infrastructure. Right. So I got introduced about these and I started learning more and more about them. And then I also, back at that time, the iOS as an operating system also got an extension for iOS XE, right? And in these iOS XE systems, there were a couple of topics which were introduced called on-box programmability and off-box programmability, right? Now, this was about like storing your Python scripts directly on the devices and running them on the device. Off-box means storing your Python scripts or other scripts for the automation perspective, and then running them where the target devices are going to be configured with the necessary configuration. And I was very much impressed with the capability of how programmability can configure network devices. Now, in my college days, I was very good at coding. I used to enjoy doing coding and all that in modern programming languages like C, C++, and all that. And I could blend my existing knowledge about coding with newly built knowledge about networking together. And that is exactly when I started my journey towards automation, right? And then there were a couple of solutions, or a couple of certifications which Cisco used to sell called NP. I guess there was one course called PRNE. Then there was a certification called NPDESI and NPDEV, right? PRNE was like Python for network engineers. NPDESI is like implementing programmability on enterprise design. And DV is developing applications for network programmability and all that. So I learned these courses and started delivering trainings around them. And that is when I professionally started getting involved into network automation and all that stuff. And back at that time, like about 2017 and 18, DevNet came out. So the news broke out that Cisco is coming out with DevNet. I quickly grabbed my eyes on them. And then I started learning about DevNet and all that. And that is when I also upskilled my existing knowledge and shifted my focus from traditional networking to automation. And ever since then, it has been a roller coaster ride for me. I started delivering trainings around DevNet Associate, DevNet Professional as soon as they came out. I was one of the very first people to get DevNet certified. I also have I'm the class of 2020 badge with me, right? So which was offered to one of the very first people to get DevNet certified. I was also um, like DevNet 500 team member. So yeah, I mean, majority of my interest got shifted from traditional networking to DevNet, and then I've been directly involved in all the relevance uh, in utilizing my skill set to teaching and then to working with network automation solutions, right? And then in 2023, I guess in 2020, I got an idea to not just work in an organization delivering trainings, but where I thought that I could actually build an organization which would focus mainly on network automation. And with that thought, we started off PyNet Labs, like Pi being the Python, Net being the network. So we're doing labs where Python and networking are combined together, and that's how PyNet Lab was formed. So yeah, and ever since then, we've been delivering trainings around network automation specifically. Also on enterprise networking, right? On I would say data center networking and security networking and a lot of other things. It's something that we've been doing, but we've always been network automation specialists, right? And this is, and then in 2023, I got my CCI DevNet, CCI automation or DevNet expert, which is the highest level and the most toughest exam in terms of the CCI certifications that exist today. It took 4 attempts for me to crack that exam. And then I've also been teaching DevNet Expert and launched several other courses around automation. This DevOps for network engineers is one of that because there are many tools. It is not just Python which gets utilized in terms of implementing automation, right? There are a lot of things, uh, including Python, then Ansible, and Terraform, and CI/CD pipelines, and PyAds, and Jinja, Docker. There are so many things that actually gets utilized in implementing full-blown network automation practices or workflows in organizations. So we thought of creating a course that actually uh, talks about implementing DevOps practices in the network automation realm. And this is exactly the idea behind this course, right? And I hope that all of you would have great time learning these tools, which we're gonna learn about and which we're gonna implement or utilize in order to implement network automation, right? So yeah, that's about my professional experience. Personally, I belong from a state of Maharashtra in India, but I've been living in Delhi for about, in Gurgaon specifically, for about 12 years now. And yeah, so this introduction, I gave this introduction so that you can understand the relevance of the skill sets about the instructor, and it will help you identify the amount of benefit that you can make by asking many questions, by being active in this particular training, and help yourself to learn more out of this particular training. Yeah. I think we can get started with our day one. Our day one is pretty lightweight. We talk about the course outline that we're gonna cover. I help you guys understand what automation really is all about, right? So that we can dive uh, straight up into the technical stack that we're gonna learn in this particular training. So let's first try and understand what the course outline is gonna be like for this particular training. Now, the title itself says that it is DevOps for network engineers, which means you're going to learn how DevOps practices can be implemented for network automation by network engineers. And if we talk about, so DevOps is nothing but set of tools and principles that are actually used in the software development practices or application development practices or anything development practices, you would say. And first of all, we're gonna try and understand quickly what really is the latest way or is the new way to manage the network infrastructure. And this is where we're gonna talk about introduction to SDN. Those of you who might have attended our Python trainings or any other automation related training, right? You guys might have had this particular topic, which is pretty common on our day one because most of our trainings revolves around automation. And to bring everyone on the same page, it is very important to uh, help everyone understand what is SDN or what is software defined networking and how, um, in comparison to the traditional networking, this new way of managing networking really helps you. So we talk about the SDN, we talk about the software defined networking, and then we're gonna dive deeper into DevOps. So we try and understand about the terminologies by talking about DevOps and net DevOps. What are both of these terminologies? We're going to understand them. And then we start with Python fundamentals, because in order to interact with your network infrastructure, irrespective of what is the type of network infrastructure you have, be it the data center networking, enterprise networking, service provider networking, whatever it is, you need to learn how you can programmatically interact with the network infrastructure. And Python is a very good and core way of achieving that. So we're going to talk about Python. We're going to understand how Python really works. But Python is not the only way. So we are also going to talk about Ansible, right, for network management or network configuration. We will learn how Ansible can be utilized. We will learn how Ansible works. How is it different than Python in terms of managing the network infrastructure automatically, right? What are the pros and cons in comparison to Python? So that given multiple or various situations and scenarios that you might end up in your production journey, you should be able to choose between which tool would kind of suit better for the use case. There are gonna be scenarios where uh, you'll have, let's say your organization has a traditional way of implementing something, and you have been tasked, or you being the manager have decided that you're going to automate this process. And now you go to your team, and your team needs to be briefed about which tool needs to be used. Do they need to develop this solution by using Python or by using Ansible? And you should be able to identify the differences and the need of the hour. Sometimes it's gonna be that Python will sound more suitable. Sometimes it's gonna be Ansible sounds more suitable. And not just these two, because you're also gonna have another tool. So I'll say managing network infrastructure using Terraform. So you would also learn how to manage the network infrastructure using Terraform. Because if you look at the IAC or infrastructure as code tools, then it is nothing but managing your entire infrastructure with tool. And there are the four main categories of the IAC tools. One is you either have ad hoc scripts like Python and all, you have infrastructure config tools like Ansible and all. You have infrastructure provisioning tool like Terraform and all. And you also have infrastructure templating tools. And that's where Docker and all that comes up. So Python, Ansible, Terraform, Docker, all of these are actually something that you're going to learn about, or is something that you're going to learn about. Okay. So when we talk about SDN, you get to know that how traditionally networks were being managed, how they are now being managed, and how you can use Python or Ansible or Terraform to manage the network infrastructure, right? And then once you know these, you also need to understand the requirement of version control system. So using version control system for code management. Now, whenever you're going to develop any automation solution in the organization, It can be, but mostly it's not gonna be just you who are working on that project. You would have peers, you would have contributors. It is possible that one project is being developed by 10 different people, and everyone needs to store their part of the development, their part of the progress that they're doing. And it needs to be stored safely, secure, and in a transaction manner somewhere. That is where version control system comes to play, right? And version control, the best version control system that you have, it's uh, it's called as Git. So you're gonna learn about how Git works. I'm not talking about GitHub. I'm not talking about GitLab. I'm not talking about Bitbucket also. Though these are cloud hosted platforms. I'm just talking about Git, which is a tool that you can install on your system and can start using its full capabilities. And later, once you start working with Git and all, then comes the GitLab, GitHub, and all that stuff, right? That's also something which you're gonna understand. And then when you do that, next is you're also gonna learn how you can build an entire automation workflow. So rather, I would say build workflow automation using CI/CD pipelines. So you will learn how to actually set up CI/CD pipelines in this particular training. Now, use cases like, for example, you have created a Python script which goes, let's say, and communicates to all the devices and maybe takes backup of the device's configuration if there has been any change. So when you run the script manually, it works fine. But are you gonna run the script every day? No. Are you gonna test everything before you run this particular script? No. So by using CI/CD pipeline, we actually set up ways about how the Python script, the Ansible playbook, the Terraform manifest can be executed again and again and again on a schedule. Okay, and how you can track each time the pipeline was executed, what were the outcomes, who did execute them. So accountability in terms of interacting with the production environment and making sure that nobody who's unauthorized gets to make any changes or gets to execute your scripts for the production environment. So we will learn how to set that up by using CI/CD pipeline. Then after that, you're gonna learn about building configuration templates using Jinja templates. Or rather, I'll just say using Jinja, yeah. Now, Jinja is a templating engine, which when we talk about scale, it lets you uh, communicate with network infrastructure and create different or device specific configurations by using templates. Okay, so we will learn about that also. Then we would also learn about validating network configuration using Cisco PyAds. Now, PyAds is kind of a tool which Cisco originally launched for internal use only for their network engineering. But later on, the tool was so good that later on they actually created or they made it publicly available. And now even you can use it in order to test automatically your network environment. Okay. So anything that you want to test. Let's say that you want a script that can go and talk to 100 devices and can check if there is any interface that has CRC errors on it. Now, can you do it manually? You can, but you'll just have to run show interfaces command on all the devices and check what the CRC value is manually. Rather with PyAts, you'll be easily be able to build a test around that. And you can do any kind of test. I just gave an example. So we're going to learn how PyAts can be utilized in order to do various tests. And after you learn all these, then lastly you're gonna learn about converting your network automation, or rather I would say converting your scripts into applications using Docker and Kubernetes, right? So that's kind of core DevOps steps. So you learn how you can actually use Docker, Kubernetes, and all in order to convert your script into a production grade application that can be hosted by the organization for internal or external use. And these are gonna be the major pointers that we're gonna talk about in this particular training. Okay. And there's also gonna be a lab environment, right? All right, I think we're good then. So that was our course outline. There are a lot of subtopics also which are included, but I just gave you a highlight about the topics that we're going to cover, right? And then we'll talk about the lab infrastructure, the timings, the flow, and all that stuff. All right, guys. Okay, so we talked about what our course outline is going to look like. Now let's try and understand how the lab infrastructure would look like quickly. It won't take much of your time. So every participant will receive a hosted lab, and that is going to include one, it is going to include an Ubuntu jump host. Okay. This Ubuntu jump host is connected from our data center to the ISP, and then wherever you are in the world, you would be able to access the jump host on our portal called lab.pynetlab.com. The credentials will soon be shared, mostly by tomorrow or so. And once you log on to this particular portal and put up the credentials which has been assigned to you, you would be able to access the Ubuntu. Whatever tools that we're talking about, right? Python, Ansible, Terraform, right? Version control system, CI/CD pipelines, everything is going to be installed on this Ubuntu machine, not on your machine. Okay, it'll be installed on this machine. Although you can install it on your machine also, but there's no use because we're going to use all these DevOps tools in order to implement configuration on some sort of network devices. And that is exactly where the second machine comes to picture, where everyone will be provided not only with the Ubuntu, but also with the simulation software called EVE-NG Network Simulator. And within this EVE-NG, we would kind of build up different topologies that would include iOS devices, that would include iOS XE devices, and so on, right? And then we would use the tools like Python, Ansible, Terraform, and all that stuff in order to implement configuration changes on these devices. And understand our motive of this training is not to create any complex topology or so. It is not a routing and switching class. It is not a data center class or so. Our pure motive is to learn that how we can interact with the network devices programmatically by using different tools, right? So we use one device or 10 device, that doesn't make any difference. And that is kind of a lab um, infrastructure every one of you would be receiving. And the best part is the labs are accessible throughout the training duration, which means even after the class hours, right? Even on weekends, you'd be able to access the lab. You'd be able to practice it whenever you want, for how many times you want, doesn't matter. And apart from that, you also get access to a private Telegram group that is created. So whenever you fail, like whenever we are done with a lab demonstration in the class, which I usually demonstrate for while we go through the topics, I would be sharing a lab activity guide in the Telegram group, and you can use that lab activity guide in order to practice the implementation that we have tried, the demonstration that we have done in the class on the labs. And it is also possible that you end up being in a problem, your lab is not working, or your lab is working, but the code is not working, your code is fine, but the target device doesn't come up. So there can be any such challenges, and you can utilize the Telegram group for the same purposes. You can just take a screenshot of the error that you're facing, or you can type in with elaboration about the type of problem that you're facing, and our DC team, including myself, will be there to resolve your queries ASAP. Right? So that's kind of a wonderful support you would get. And the classes are gonna happen, um, I guess on 8:30 p.m. The time and everything is, yeah, you guys already know that. And this is basically what the flow of the training is, right? And that is what we wanted to talk about on our day one. We keep day one very light and easy for introductions, for understanding, right, and all that stuff. And then from tomorrow, we dive straight into our topics, starting from introduction to SDN. We will also talk about fundamentals of DevOps and all that tomorrow itself. And then from the next one, would jump into Python and all that stuff. And this is how basically the course flow is kind of gonna look like. Right? Awesome. I think we're pretty good then. So yeah, that was all for day one. Nice and easy. And there, that's my screen. Yesterday, which was our very first day about this training, we talked about the course outline. We talked about what we will be covering. We talked about how the lab infrastructure is going to look like. And in today's session, we're going to get started with the very first topic of the training, which is going to be introduction to SDN, or you can say software defined networking. And when we talk about software defined networking, we try and understand that how networks have been managed in the past, and how that approach is slowly changing with the introduction of a lot of SDN solutions, SDN methods, and all that stuff. And while we talk about that, first of all, we need to understand how traditional networking really functions, right? And then understand the limitations of traditional networking and then compare it with the architecture of SDN, which is gonna help you clearly identify the gaps, clearly identify the benefits, right? And then understand how DevOps philosophy really fits into the new way of managing the network infrastructure. So when we speak about the traditional networks, Networking, I would say, has been very traditional uh, since the beginning. And in traditional networking, we work with a lot of types of devices, right? We work with routers, we work with switches, we work with firewalls, we work with load balancers, right? We have WLCs, we have IPS, we have IDS, right? And so many other things. And all of these equipments or devices, they are manufactured by various organizations, including Cisco, of course. We have Juniper, we have Palo Alto, right? We have Nokia, or we say Aruba, right? Sienna, Huawei, F5, Fortinet, and so many. And all of these organizations, via their hardware and software, they provide one or the other way to manage the infrastructure. If you talk about any device, right? For example, I have a router, and then that router is connected to maybe a management PC. And on that management PC, you would use a tool or a utility like putty. And what you would do is on the console port, you would kind of use a console cable as a medium, and you would actually connect with that particular device and send the CLI commands to the device. And the device will kind of be configured and start behaving in the way you want. But this is not the only way, right? I mean, you cannot really go and communicate to every single device and put on the commands by connecting to that device physically. It becomes tedious, specifically when we think about medium or large scale infrastructure as of today, right? So what you can do is you can expose that particular device over the network. And when you expose that device on the network, then anybody can kind of act as a remote user and then can connect with that particular device by using various methods nowadays, including SSH, including Telnet, including HTTP. There are so many ways you can communicate with the device, like kind of using the remote management protocol and all, right? And in that case, your device, when it is configured properly, it will start behaving as per your expectations. And this is kind of traditional network. Now, if I give you a little bit of backstory, earlier what used to happen, organizations would procure hardware from a specific vendor. Like they would go to Cisco and they would say that procure all the devices from Cisco, and then they would hire network engineers who specialize in configuring Cisco's hardware, right? And then your hardware will be deployed, your production is ready, and your network is working all fine. But later on, this trend changed, right? People or organizations, they started implementing multi-vendor network deployments, whereas they would have some devices from Cisco, some from Checkpoint, some from Fortinet, some from F5 and all that. And this is exactly when organizations also then required engineers who knows how to configure different type of infrastructure, different vendors from their infrastructure. So as I was saying, when organizations started implementing deployments of different vendors, then they would also require people who know how to configure devices of multiple vendors. And that is exactly where network engineers started to upskill themselves. For example, imagine yourself being a network engineer who only knows how to configure Cisco's device, but your colleague knows how to configure Cisco's device as well as Juniper's device, as well as the Checkpoint's device, as well as the uh, load balancers also. So he or she would definitely carry more value in the eyes of the employer and maybe would get more recognition in terms of the professional achievements. So you would also step up and you will try to upskill yourself and learn how to configure devices of different vendors. But it is not easy, right? Because being able to configure devices of different vendors requires you to know how commands really work, how the configuration really works on those devices, what exactly is the syntax that you need to follow, and blah, blah, blah. And if you end up doing some misconfiguration, then it can actually bring the entire network to a standstill, which is not something your organization would want at all, right? So this was being considered, or this was observed as one of the bad practices that were being followed in the organizations, and that's where the manufacturers came up with another way to configure these devices or these infrastructures, and that's GUI. So devices like Cisco ASA, for example, or maybe various other devices that we see nowadays, right? So you could configure the ASA, you can connect that particular ASA with the same PC, but you could configure it by using CLI as well as by using GUI. So if you want to configure it by using CLI, you would use PuTTY. If you want to configure it using GUI, you will use a utility called ASDM, Application Security Device Manager. And without knowing any single command of the ASA, you would still be able to configure ASA because of the GUI. So it kind of gave a little bit of ease to network engineers, and network engineers started to be being able to configure different devices without really going the hard way of learning the CLI commands, remembering them and using them and all that. And this was an approach which was, uh, I would say, embraced by a lot of organizations, and many organizations started introducing GUI capabilities in their devices. Right. I'm not saying ASA was the first one. I'm just saying that as an example that when GUI management was introduced, then it started acting as the main way to manage the devices. And this is from the management side. Now think from the device's performance size. Let's say that you have a very normal network. For example, we have a router one. That particular router one is connected to a switch, and the switch is connected to some endpoints. And let's say over here we have 192.168.1.0/24. Then you have router 2, and router 2 has another switch, another set of endpoints, and we have 192.168.2.0/24. And then you connect both of these together, and that would kind of be 192.168.3.0/24, right? And let's say you have implemented static routing in that. Now you have implemented that. It is, of course, that these endpoints will be able to communicate with these endpoints. So, like if you want to send the packet from this PC to this PC, the traffic will first of all go to the gateway. The router one will perform some lookup into the routing table and figure out what's the next hop. And then the traffic will go to R2. R2 will also perform some lookup into the routing table, and then the traffic is going to go down. And similarly, the return traffic will follow, right? So that is how the communication used to. But think of it that forwarding the traffic from one point to the other point, is that the only thing that your routers or switches are going to do? Not really, right? So a network device, for example, a router, it has different functions that it has to perform, right? I mean, it has to, let's say, check the destination IP address in the routing table in order to figure out where to forward the IP packet to. Then it has to check the routing protocols like OSPF, EIGRP, BGP, and all that. All of that are required to learn the networks that are installed in the routing table, right? Then the device also has to use ARP or address resolution protocol to figure out the destination MAC address of the next hop, right? Or destination, and then change the MAC address, something that we know as MAC stripping, right? Then every time the packet crosses a hop, the TTL value needs to be decremented by one. Then to ensure the integrity of the data, the device has to calculate the CRC, cyclic redundancy checks, and all that. So there are tons of things that a device has to do apart from forwarding the traffic, right? And all of these tasks are performed by three planes. So what you have, I mean, every device kind of has one, a management plane, second, a control plane, and third, a data plane, right? Now, think of it this way that you, being the user or the admin, you communicate with the management plane bidirectionally. Because management plane is the one who's responsible for this GUI or CLI utility that the device has. So whenever you type any commands on the device, whenever you execute any configuration using the GUI on the device, you are interacting with the management plane of the box. And then the management plane tells to the control plane that this is what the user wants. And the control plane applies that actions onto the local processor because control plane is responsible, or control plane is nothing but CPU. Okay, it is responsible to activate or enable the processes that the device has on the physical box. So whenever you use a command router OSPF and the process ID, then in the CPU, that OSPF process and feature is going to be enabled so that the device starts sending hello packets, it starts receiving hello packets, it starts processing hello packets, it starts forming the neighborships and all. All of this is done by control plane, but it is notified or enabled by the user via the management plane to the control plane. And then it's going to take and install all the routes that are going to come up, right? All that stuff is going to happen over there. And then control plane is going to take some decisions. For example, let's say that we have router 1, then we have router 2, router 3, router 4. And we also have router 5. Router 5 has a loopback called 50000. Now router 2, router 3, router 4, they all are connected to router 5. Router 2, router 3, router 4 are also connected to router 1. And this this 50.0 route, it is going to be sent out to all these three OSPF neighbors. And these three OSPF neighbors will also send the route out to the R1. So when R1 receives this route 50000 from R2, R3, R4, it needs to decide which is the best route. And then that best route is going to be installed into the routing information base of the device. If all the metrics of the routes are same, then all the routes will be installed because OSPF supports load balancing. But if it would have been BGP, then only the first received route will be installed in the routing table, given that the BGP attributes are same for all the routes. So there are a lot of these factors which control plane checks, and then it installs that route, and then it also informs the data plane to start forwarding the traffic according to the decisions that it has taken. Because data plane is responsible for the line cards or interfaces, whatever you call it. So you can see the hierarchy that the user only communicates with the management plane. The management plane communicates with the control, and the control communicates with the data. You cannot jump the gun. User cannot communicate with control or data plane. That's not possible. A management plane cannot communicate with data plane. That's not possible, right? So it has to be under the hierarchy itself. So when we look at that, the control plane, of course, is responsible for exchanging the routing information, building the arc table, right, etc. Learning the MAC addresses. If it's in the case of switches, the control plane is about learning the MAC address to build the MAC table, learning the spanning tree protocol to create a loop tree topology, right? Building arc tables, running routing protocols, OSPF, IGRP, and all that stuff, right? And data plane is like it's responsible for forwarding the traffic. So it relies on the information that the control plane supplies, encapsulating, decapsulation, adding or removing the .1 queue headers, matching the MAC addresses for forwarding, matching the IP destinations, right? Changing the source and destination addresses if you're using NAT, dropping the traffic because there is ACL in place, right? All these decisions are done by data plane. And all of these three planes, they actually do exist on router one, router two, switch one, switch two, or whatever network devices that you have, firewall, load balancer, whatever it is. You're going to have management plane, control plane, and data plane available on these devices. Now, that's how traditional network behaves. Now, we need to understand what exactly is the limitation of this traditional network, right? So, what we're looking at right now is the limitations of traditional network. Now, here's a classic example. Let's say that we have ISP who's providing us reachability to few of the branches that we have in the organization. Let's say we have one branch in Delhi, another one in Mumbai, and let's say the headquarters is in Bangalore. Okay, this is the and in the Bangalore, we have kind of few servers. Let's say this is one of the server that we have. And on that server, we have few virtual machines. So virtual machine one, virtual machine two, virtual machine three. What are these? These are nothing but business applications. Okay. Can be anything, ERP solution, CRM solution, whatever it may be. And then to provide the to perform the daily operations of the organization, these people sitting in Delhi office, right? They have to actually access the applications that are hosted in the headquarters. So obviously you would put these servers on the network. So maybe you have a few routers, a few firewalls, a few maybe layer 3 switches, a few layer 2 switches, right? And I would kind of connect those to the servers. Maybe I'd have a mesh network or so on. And then I'd connect both of these routers to the ISP. So this way you can actually provide connectivity. And there can be a lot of things which would be implemented. Like you would have VPNs, you would have BGP neighborships, you would have OSPF neighborship internally, you would have access control list, you would have NAT, right? You would have spanning tree protocol, you would have XSRP, you would have IP addressing, you would have inter-VLAN routing, you would have VTP, and so many things, right? And this kind of can be considered as the core of the network. This can be the aggregation of the network, and this can be the access layer of the network, right? And in this case, the traffic will actually flow and make it communicate with over here, right? So this is how usually it works. Now, what is the limitation over here? The limitation is because every single device has its own management plane, has its own control plane, has its own data plane, it becomes very slow It becomes very manual. It becomes very error prone. Why? Let's say that everything is working fine right now. And the company, the organization has a requirement suddenly that they need to install three new virtual machines to support a new application. Okay. So I would say new business application. And you installed three new virtual machines for that application on the existing server. The virtual machine guy, the virtualization guy, would just come up and do his or her job, maybe in an hour or a couple of hours, or maybe the entire day, and then makes those applications ready and locally accessible. But will that application be accessible to the people sitting in Delhi and Bombay office or Mumbai office? Not really, right? And in order to provide that accessibility or reachability of the new applications, you would have to manipulate all of this, right? That too on all the devices. Why? Because every single device has its own management plane, control plane, and data plane. You would have to change the VPN, you would have to change the BGP, allow new subnets, you have to advertise new subnets in the OSPF, you'd have to fine tune your access control list, fine tune your NAT, fine tune your STP, create new VLANs for that, and all that stuff. So you have to plan a proper maintenance window in order to change the configuration, test it, and then kind of deploy it. And the major limitation, like I said, if you do it device by device, then it is slow, it is tedious, it is error prone, right? And with the growing complexity of the network infrastructure that we see nowadays, it is risky, of course. And that's why organizations started looking at other ways, right? For another way of how that configuration can be done. And this is exactly where SDN, software defined networking, came into picture. And SDN, with its very basic approach, it changes the way how networks are being managed. What SDN does, you let's say have the admin machine. Now the admin machine is gonna communicate with a SDN controller. And the controller via ISP or directly is gonna manage the infrastructure. Now in this case, the admin earlier it was going to the infrastructure directly by either using the CLI or the GUI. But now the admin goes to the controller, right? And not necessarily that controller has to be a separate device or a separate server, right? Controller can also be a tool that is being installed on the admin machine, or it can be a separate virtual machine that is being installed in the server and then being utilized. There are different forms of the controls. But for now, conceptually, let's try and understand that it's a different element. So instead of going directly to the infrastructure now, you go to the controller and you specify your intent that, hey, controller, let's say I want to configure OSPF on 10 devices. Okay. Now you tell that to the controller. Controller says, okay, which devices do you want to configure? The admin says, I want to configure this R11 to R20. Controller says, okay, I have the access of those devices. Can you tell me what process ID, what OSPF area ID, what networks do you want to configure? Admin say this, then this. For R11, that's my network, that's the details. For R12, that's the details. For R13, that's the details, and so on. And then controller, it prepares the device understandable configuration for each device. It prepares the config. Now, till this time, there is no configuration that has been done on the device. And after preparing it, the controller will show that config to the admin that, hey, See, based on your input, this is something that I have created for each of the device that you want to push the config, and give me an OK if you want to push this config. Now, as we confirm it, that go ahead, the controller will push that config to all the devices that you have. I mean, all the devices that you highlight. And while it does that, the controller also validates that whether the configuration is syntactically correct, functionally correct, logically correct, right? And if so, it is going to push that configuration on the box. Yeah, that is how it actually works. So you can see that in this particular case, the controller becomes the management plane as well as the control plane. And then the infrastructure just uses its data plane for forwarding the traffic. So SDN is something that you decouple the control plane, management plane, and data plane from each other. Earlier, it was a scenario where each of the device will have its own management plane, control plane, data plane. But now the infrastructure devices just focuses on the data plane locally so that they can forward the traffic with the best of their capabilities. And the management planes, control plane, and all that can be centralized in a, and that is a great or a huge revolution, huge change in the way of how networks of any scale were being managed earlier. And it is changed now. It is a different way of how you manage the configuration. When in our case, now there are different flavors of SDN or software defined networking architecture. Okay. One is called as pure SDN, and second one is called as partial SDN. Pure SDN is where the infrastructure will only retain the data plane, and the control plane and the management plane and everything is going to be centralized to a separate controller. And partial SDN is where the infrastructure will retain all planes, but still be managed by different tools. Now, if I talk about some examples, for example, SD-WAN is a pure example of pure SDN, right? But let's say NSO, which is another solution by Cisco, it's a pure example of partial SDN. Why? Because in pure SDN, if let's say you're managing a router of the SD-WAN solution, you get vManager over there. Those of you who knows what is SD-WAN and how does it work knows that you get something called vManager over there. And you also get something called vSmart over there. Okay, as two different controllers. This handles the management plane. This handles the control plane. Your device is nothing but the data plane. So the admin always communicates with the manager. You go and log into the manager GUI, you create some config, and now when you select that you want to push the config, as soon as you push the config, the manager will speak to the vSmart, which is the control plane, that hey vSmart, can you push this config to the device for me? And the vSmart actually goes and communicates to the device and pushes the config for them. Right? Now, in this case, can you directly go and do the configuration on the device using maybe CLI or so? No. You can only and only manage the device via the control. That is the case of pure SDN. And partial SDN, now if you have, let's say, NSO as your controller, so you log into the NSO, you say, I want to perform this config change on my device. So you tell to the NSO that configure OSPF with these parameters on my router. NSO will go and push that configuration to the device. But can you also log into the device using the CLI or GUI directly and perform the config? Yes. So you're able to do it via controller as well as via directly. Not via directly as well as directly. Yeah. So and then that's why we call this as partial SDN. So there are both types of SDN solutions that exist. In our training, in our class, our motive is not to use a specific type of SDN. Our motive is to focus on how we can use partial SDN tools, and that's exactly where Python, Ansible, Terraform, Docker, and all that stuff comes in. So instead of having a dedicated controller, how can we install these tools directly within the admin machine and programmatically communicate with network devices instead of directly communicating with the network devices using CLI and G1? Like think of it that if I have 10 routers, right? So one way is I go to each router, take CLI access, SSH or Telnet, whatever remote management protocol. You use that, you go to each device and you configure that. That's one way. Or you write down a simple Python script that goes and communicates to each device automatically as you execute the Python script, right? And then you perform the config. So which one is better? Of course, the one with the Python script, because you will save a lot of time. You can also ensure a lot of validation and all that stuff. So we're going to understand that how this partial SDN really works and how all these tools and all can be installed on your machine and can make communication possible for you, right? That is what we're going to look at, and this is what SDN is all about. So over the past few years, the industry have seen so many tools that are being introduced, right? Which some of them are really revolutionary tools in terms of managing the network infrastructure, right? For any scale, small scale, mid scale, large scale, very large scale. Or I've seen people using scripts to communicate with hundreds of devices and maybe perform backups or so on. There are so many use cases you have. People often use telemetry stack there where you schedule a Python script. That Python script, with the help of CI/CD pipeline, every morning it is going to go and communicate to each device and it's going to check if there is any interface which has CRC errors, if there is any interface which is in error disable mode, if there is any interface whose administrative status is up but there is no IP configured. If there is any such interfaces, collect that information and create a report and send it via email to the stakeholders automatically. So before the stakeholders actually come on in the office, they have an email or they have a Slack message or a WebEx message or a WhatsApp message, whatever message, right? Which highlights the state of the network. Whereas instead of manually checking each infrastructure device, you simply have a script that collects information from each of the device and lets the stakeholder know that what's the state of the network, which saves tons and tons of time, right? And this is just one of the examples. You can have so many examples like these, which highlights how the networks really are being managed with these advanced tools and advanced ways to communicate with network infrastructure. So this was our discussion around SDN, right? Now we will try and understand that how DevOps is really taking things further, right? And what exactly is this terminology DevOps or net DevOps coming from? So now we're talking about fundamentals of DevOps. All right. Now, in order to understand DevOps, or you can also say net DevOps, the term DevOps comes from two different or full terminologies called development and operations. Together, it makes it DevOps. Basically, in the traditional way, organizations used to have two different teams, right? One would be the development team who would actually write the code, would make your applications, make your softwares ready. And then there will be the operations team whose responsibility will be about making that particular application publicly available. So it is about pushing that application or pushing that development out onto the production environment, right? And there would be lots and lots of tools that will be utilized in order to make this happen. Now, when you look at the older practices, whenever you have any software that is going online or that is being made publicly available, then the organization's engineers will also track and look for the the bug fixes, right? Then the bugs that would be highlighted and certain other scenarios. So in recent years, what happened, certain industry trends and innovations have transformed the way business is done, right? And businesses are transforming to include mobility, to include IoTs or Internet of Things, and cloud services to meet the market demands, which actually requires agility, simplicity, speed, and all. There is a terminology which is getting very popular called cloudification of applications. What is this cloudification of applications? Earlier, organizations used to host their development, their applications, their code, right, on the infrastructure that was locally available. So on-prem infrastructure. But nowadays, organizations are moving away from hosting their applications locally in the local data center, and they are actually hosting the applications on the cloud infrastructure, which means someone else's hardware. So organizations like GCP or Google Cloud Platform, AWS, Azure, all of these organizations have became pioneers, became very popular in terms of providing the infrastructure on rent. And there are multiple models also, right? I'm sure you might have heard about models such as software as a service or SaaS, right? Platform as a service, infrastructure as a service. All of these are models about what you being an organization would like to rent out. Would you like to rent out the entire infrastructure like the servers and then host whatever you want on them? Would you like to rent out the platforms like operating systems and then host the and let the provider manage the hardware? Or would you like to rent out just the software and let the provider manage the entire backend? And accordingly, the provider is going to charge you money for that, right? So because when you host your application being an organization on the cloud, it removes all the capital expense as well as the operational expenses behind maintaining the hardware, behind keeping the hardware always up and running. Like the capital expense is like purchasing the hardware, purchasing the servers, and operational expense behind it is keeping that server always running, maintaining the air conditioning, maintaining the power supply, maintaining the backup power supply, right? Maintaining the team, providing salaries to the team who's managing that data center and all that. All of that comes under operational expenses. So organizations nowadays do not want to spend the capex and opex behind hosting the application. Rather, they want to pay a monthly rent and then let somebody else manage that physical data center. They would just remotely access the data center and host their applications. And since a lot of organizations are doing this, this trend is called as cloudification of applications. And this transformation introduces, of course, a lot of agility, simplicity, speed, right, and innovation, which is coming out to be as recent market trends. And this transformation which is kind of considered to be as a digital transformation, it requires businesses to introduce new tools, new cultures, and processes to change the way things are done, especially regarding how developers and operations relate to one another, right? So the speed at which businesses changes and adapts to new requirements, it is no longer fast enough to adapt the current industry expectations, right? To meet the demands of this transformations, organizations are exploring DevOps and how it can be applied within an enterprise to allow a faster or safer and certain other scenarios, right? So there are two words, right, in the organizations. If you look at the problem, then you need to understand what exactly are the responsibilities of the developers or development team, and what exactly is the responsibility for the operations team, right? And if you look at that, the developers, and then we have operations team. So the developers have responsibility of writing the code or writing the software, right? It has to basically create working code, the code that actually works. They have to define APIs. Okay. They have to create libraries for the applications. They have to plan the sprints for newer releases of the applications and so on. And if you look at them, what is success according to them? Success for developers is that the software actually worked or the application is working fine, right? Similarly, if you look at the operations team, then operation teams cares about something like factors like everything is stable. This is what operations team really care about. They care about creating standards. They care about creating templates. They care about uh, the availability of the code and all that, right? And for them, what is success? For developer, sorry, for applications guys, they have to make sure that the software is stable. The success for them is that the backup, let's say, and restore facility is working fine, and the application or the software is working within the defined thresholds, right? If this is ensured, then the operations team is happy. So when you look at this, traditionally, the software developers um, and the IT operations team, they are separate silos. The software developer focuses on creating features and delivering applications. The operations team focuses on enabling the connectivity, ensuring a reliable and stable environment so that the developers can deliver value. DevOps, when you combine both of them, right? The DevOps methodologies breaks down the silos, right? The gap, the communication gap between the development of the software and the operations of the deploying, right? And maintaining the software. So the main benefit of siloing the development and operations team was that each team could specialize and use its expertise to deliver value. And before enterprises embarked, I would say, on digital transformation when applications were used to be hosted locally on-prem. This approach was common and it allowed enterprises to keep up with the industry trends. But now that the digitization, the cloudification has disrupted the enterprises, then IT operations cannot focus purely on network connectivity without paying respect to automation, right? And DevOps culture. And applications are no longer released monolithically, right? Every few years. Earlier, what used to happen that organization would release version 1.0. Now, after 6 months, 8 months, a new version of the application will come up with new features, addressing the bug fixes and all that, right? That was the term, or that was the standard earlier. But applications now, they continually have new releases. We see on our mobile phones that we get updates to applications every now and then, every week, every or twice a week, I would say, right? And they require regular updates to the IT infrastructure and all that, with the expectation of a quick turnaround. So first, developers care about writing software. They care about APIs. They care about libraries and codes and all that. The software they write should be of high quality and it should meet customer expectations. And success is determined by whether the software does the job as expected and if it was completed and delivered on time, right? However, the developers traditionally do not pay as much attention to what happens after the software application is delivered to a production data center. The issue creates a divide between the development and the operations team. And on the other hand, the operations team care about software standards and stability, right? The operations department, they has rigid change management window for rolling out new updates, right? So success for operations team is represented by a state by a stable and functional environment, right? So developers and app operations team, they look at the world from different perspectives. What we can summarize is that developers wants to release new versions of applications and new products as fast as possible, whereas operations team do not want that. Operations team wants a reliable and a stable environment. They do not want so many updates or so on, right? And that's kind of a gap, right? That's kind of like a wall of confusion that you have. And this is exactly where DevOps comes into picture. So what is DevOps in this particular case? Now, you can say that DevOps is a philosophy, or you can also call them as principles that are followed to fulfill today's expectations of digitization, right? And if you look at that, then we have to understand some of the key characteristics of DevOps. One, DevOps actually changes the operational approach and mindset. It also changes the culture. It enhances the level of communication between the teams. It also automates all the things that you have in both the teams. It also delivers the software, or you call them as products, as well as services faster to internal team or to customer, whosoever it is. And it definitely requires commitment at all levels. And lastly, it breaks down the silos, right? And it improves the collaborations. Silos is like whenever there is a gap of communication between teams. So DevOps do not really interfere in the, or sorry, development team do not interfere in the responsibilities of operations and vice versa. That's called a silo. So when you look at this, when you merge both development and operation team together, then under DevOps, you have to follow a certain philosophy. You have to follow. So it is not a tool really. If you have an understanding that DevOps is nothing but using a piece of software and then you would be good at it. No, it is not. DevOps is like following particular philosophy, following particular practices, using particular codes or using particular way to deliver code software, right? And then there are certain tools which enables you to follow the philosophy, to follow the culture, to follow the best practices that are highlighted in the DevOps model. And DevOps is not a hardware that can also be purchased, right? Or a piece of software that can be installed. Although it is like a collection of tools that are used in DevOps culture, right? And organizations that actually embrace DevOps, they're embracing a new culture. There is a way how code is written. There is a way how scripts are executed. There is a way how the code is stored. There is a way how changes to the code will be done. Right? There is a way that how frequently updates will be released. There is a way how the bug fixes will be done. And knowing all these ways by the DevOps method is called embracing DevOps in the organization, right? So you have to understand the culture, you have to understand the automation, you have to understand the management philosophy, you have to understand the measurement of the operations, you have to understand the sharing capability, the sharing mindset about the code, right? All of this needs to be understood properly in order to fully implement DevOps. And there are various practices that are used through it. And slowly we're gonna get to know about them. Slowly we're gonna get to know for each of the practice what exactly are particular tools available and how to use them out. Right? So that is what DevOps in a fundamental idea is all. So I think we're pretty good. That is something which we wanted to talk about in today's session to get an understanding about STN, to get an understanding about uh, how the DevOps really go like, right? And in the tomorrow session, we'll be talking about all the best practices, the tools that are there, the workflow that we need to build, what exactly are different tools and the responsibilities or the features of each of that particular tool is going to be. That's what we're going to talk about. And then we'll also probably start with the Python fundamental section, right, in the lab. I hope you enjoyed the session and I'll see you tomorrow.